Good afternoon and welcome to this third seminar of the Digital Classicist series in London. Today we are going to have Jari Pakkanen, that is an old friend of Digital Classicist, and he will talk about digital tools for classical archaeology and architecture, combining total station drawing and photogrammetry in fieldwork documentation. But before we start, Eleanor will say something about our next seminar.
To just put the page up for next week.
Yes.
So everyone is. Well, thank you very much. So, hi everybody. I'll be chairing next week, and I just wanted to let you know it's going to be a little bit interactive than normal. And Juliana will be coming in to teach us how to use Wikipedia in teaching ancient history. So if you want to, bring a laptop or something you can edit with. If you're already registered as a Wikipedia editor, great. If you're not and you do want to do that, get beforehand, it's really easy to do. If you don't want to do that, you can come and peer over someone who is, so I'll bring my laptop. There's a kind of a maximum of 6 people that can be wiki editing on any one place at a time, otherwise we get kicked out because they kind of manage things for sort of troll factories, right? Troll factory. So we will only be able to do sort of those of us here. If you are following along online, obviously that restriction doesn't apply to you and you can join in anyway. Don't feel intimidated. You don't want to do it. It'll be really interesting, and we haven't actually worked out the format yet. It won't be the usual chat plus discussion. We'll do something much more mixed. So I hope it'll be a lot of fun because I'm really looking forward. I've never been able to make Wikipedia editing work in class yet. So this is my chance. Next year, my undergraduate special subject students are going to benefit enormously from this. So, okay, I will shut up and hand over back to this week's speakers.
Great, thanks, Eleanor. And now we leave the floor to Jari.
Thank you very much. And okay, we're back to the beginning slide. So I will go through quite a few case studies. And the reason why I have the Finnish Institute logo here, I was seconded as the director of the Finnish Institute for 4.5 years, and I finished at the end of 2017. So basically all the case studies are fieldwork projects of the Finnish Institute or connected with a 3D digital project that I started at the Institute from 2013-14 onwards. And my normal post is at Royal Holloway, and I'm back to that post as of beginning of 2018. Okay, but we actually have to go back for the total station drawing and the, let's say, intensive and extensive use of line drawing with a reflectorless total station. We have to go back 12 years. And I was in a position then to start actually 2 projects at the same time. So I was working at Archaeology on Poros, a sanctuary of Poseidon, and that was a Swedish Athens project that I was collaborating with architecture, directed very well and Arto Penttinen. And Jari on both sides in the middle of the project and started becoming sole director of the project. And at the same time, I started underwater team, so both. And I had quite an actually that excavators you have is to and most even have a reflectorless total station 12 years ago. Photogrammetry was not really working that well at that point. We did do that in Kalaurea, but then we did more or less and in any way that's now it's basically mainstream technique. And scanning was way out of our budget, so there was no way that we could afford I think at the time was closer to 100,000 that you'd be looking at. So 50,000 for a scanner and another 50,000 for the software, hardware to run it. And there's no way we could basically afford that. So just briefly about Kalaurea, the sanctuary of Pakkanen, a very interesting sanctuary that there's half a dozen monumental buildings, but basically all of the architectural blocks have been recycled into mostly local monasteries, and that's resulted in a situation where the sanctuary has not really been attractive to normal classical archaeologists who want to have nice standing buildings by Swedish archaeologists, the first excavation project by the Swedes in Greece, and then more or less forgotten until the later part of the 90s that the Swedish Institute started a new project, and then I started 2007 with the architectural project at the same time as the main big project by the Swedish National Bank. And one of the first things we're thinking that when we started with the excavations is that we did have as always, a very, very good archaeological architectural illustrator. And one of the first things we discovered that we had a fairly spectacular statue base of 4 blocks, and in the first season, and when we decided that we can actually run the publication out as fast as we can, and there after the first season, during the second season, when I started putting the blocks together, they didn't actually join quite too well. And the reason, you can actually see it here, is that what happens that human brain is incredibly powerful in making things more regular than they are. So if you have a rectangular block, you will actually, I'd say, I've had training in drawing architecture, and this is I would have done the same thing, so actually draw it as a rectangular block. And so there's a limited amount of measurements you can take when you do hand drawings. And the top one is the hand drawing, and the bottom one is then the subsequent total station drawing of the same block. And you can see that that's with the lower right corner. It's no wonder that the blocks don't actually join. So that's and sort of discrepancies of sort of 5 to 10 centimeters are quite often what you can actually expect. Surprisingly, you can actually expect that in hand drawings of blocks, and especially when they're broken, then they get to be very, very difficult to make drawings out of. And so I went back to the field and just tried to see that how you can kick a total station. So what you can do with it. So when you do reflectorless drawing, it's actually it's very quick. So you basically just point the laser pointer, and you click it, and when you have software that actually can connect the dots, you get a nice 3D drawing out of it, and very quickly. So I'll show you some of the examples that we've been then doing later on with the total station. And this is the raw data that comes directly out of, so from where I was doing, I was just moving the total station around the blocks, and this is the documented data. So I have done no manipulation at all. So just downloading the data from the total station and taking it to CAD. And okay, I did do when I was recording it, I had different layers for the texts and different blocks so that they could be separated, and you can actually make them joint together. And the next thing was that for the final publication that came out in 2009, I wanted to actually show that you can't tell apart, that if you slightly work with the drawings afterwards in 2D drawing programs, they look more or less exactly like the ones that you do with hand drawings. But except now we know that the lines are spot on, so they join. So even the unfitting blocks, they actually join together and not with sort of clashing corners in them over there. And then you can use the 3D documentation as part of reconstructions and so on. But it's not only small scale things you can do with the total station drawing. So we basically have documented all of the half a dozen monuments or buildings at site, so stone by stone. Okay, let's take it back. So we were actually 2 people doing the monumental store. That's one of the better preserved buildings, actually even some blocks in situ for it. And I'd say we did about a bit more than a week's work. So 2 people drawing the stones, and you get the wireframe drawing out of it. And I'm just saying that then you can basically, it's already processed, so there's very little post-processing. Most often with the digital techniques that you have, the post-processing is the problem, so that you end up with gigabytes of data, and once you have to get to the publication, it will take weeks and weeks of processing time to actually get something out of them. And the line drawing with the total stations is quite handy in a way that that you do get minimal post-processing necessary, and they will, depending on how good you've been actually in the documenting the field, you will be able to get the sections and elevations and plans of the buildings out very easily. And that's already published sort of 10 years ago, and so there's the references on the, if you don't have it, you can actually get it quite easily from the YouTube broadcast. And when I started at the Finnish Institute, the first thing was that the first versions of the link programs from total stations into CAD I had actually done in a script language. And once you started getting thousands and thousands of points, I think my current record is sort of 7,000 points in a day, with actually using several total stations. But that's so drawing fairly densely the blocks. That meant that it took quite a long time to process it with the script language, the process. And since I had the funding for the Finnish Institute, so I actually got with a company in Finland to do a Windows console program out of this. So basically the same algorithms that I had for my own work with the script language, that then actually doing a console program which is lightning fast, so that you still have to do a bit of post-processing. So depending what kind of connections you have, most often actually you find the fastest way is record during the day and then just take it to the USB stick or download it with the cable and process it one go, and then go the next day if you miss something in the documentation. You go back to the same, you actually process the CAD data. You can take the laptop or a tablet that you have with your CAD, you can take it to the field, and you can then just document whatever is missing from there. And the good part is that it makes a DXF file out of the total station data, and that DXF is something that you can actually open with any CAD program. And what I've been doing, I haven't put this online because there's a couple of small bugs with the program that I have to actually explain. So it's not available online, but I've given it to all the students that I've trained and actually quite a few of professionals who work in the field as well. So they have access to so if you just drop me an email, actually I can send the program and the guidelines and explain where the difficulties actually currently lie with using the program. So that's the drawing with the total station part. And nowadays, so let's say past 5 years, we regularly use photogrammetry, and these two can actually be combined. So using the standard, most often we tend to use Archisoft Photoscan, so now which has Meta Shapes, I think is the current name, and that we use for the photogrammetry. But there's also very good freeware programs that are available for photogrammetry that you can use. But usually a bit limited number of photos you can use, but at least for object type of work you can use them. And I'll take an example from Salamis, a project that we started in 2016. So together with the effort from the Pyros and the islands. So it's on the island of Salamis, and at the Bay of Ambelakia is the old team center, actually quite a large town Center. And the first season, 2016, so Finnish Institute Field School, but then collaboration with Leiden University, so Professor Brisbart's Set in Stone project, and also then Holloway. And as you see, it's actually relatively easy to borrow and buy second-hand stations, and because there's so many available that you easily get up half a dozen if you have some friends who are working in Greece. That's you just bring everybody together and you can get them. So I think I've bought several total stations that's now very good ones you can get for £2,000. That's sort of now it's getting to be 10 years old, but there's still excellent machines. And I'll show you one of the examples how we've organized this, since it's a field school, so training students. And basically, we have an excavations done in the past, mostly in the past 25 years that have been partially documented, but not entirely. So we've done all through the city. We've gone through the old excavations and cleaned up the trenches, at least that the architecture is visible. We haven't actually been able to do everything, like as you see here, that parts of the trench sides have been collapsed. But we didn't start cleaning where there's nothing visible. But wherever there's something visible, we actually cleaned off even the sides of the trenches. And that's just the paper on that, where I do discuss the combinations, came out fairly recently. And I just took out, so once it's been cleaned, then the students have a task of making their own photogrammetry models out of it. And this is one of the student photogrammetry. So it's nice, limited. So it's the Greek way of excavating quite often comes with the 4x4 trenches, and then you leaving the bulk, then you remove the bulk at the last phase. And in this case, since the excavations were never finished, the bulks are still there, and even the lower levels. So basically, the later, most historic levels of the houses have been reached, but there are really lower classical ones underneath. So at some point, hopefully that will continue. So photogrammetry is there. Then that you add the line drawing documentation on top of it. So they combine automatically. You can just import it. You can use the colors and so on, and you can then compare the two. And then you do see occasionally that even though it is student work, so there's a tendency that often you're forgetting one lines and then they have to go next day. But altogether, we have managed from 2016, 17, 18. So 3 years, we've done quite extensive documentation of the area. So that's all of these areas inside the city walls. So the city walls run. We have one of the corner towers preserved over there, and we have towers preserved also on the west side. So we know the extent of the city. It's like that. But we've actually documented all of the city walls, the houses that are there. And a small sanctuary in the middle, but we also carried out at the same time full-scale geophysical research. So basically all of the open areas we've also covered with geophysics. So now we know where the previously excavated houses are. We know the city. I'm actually skipping here the geophysics and leave that for another talk. But we have now a very good idea of the whole city as it is, and I'll show you what happens when you combine the half a dozen total station works and the students. So that's the one of the areas where we have the houses excavated. Probably was about 5 working days that we've done. We covered all of it. So both cleaning and then document with stations and photogrammetry. I'm going to take some that actually is now fairly well published, but just show because it's fairly unique that you can actually combine underwater work with line drawing with total stations, and the Kilini Harbour project is unique in that sense. We have a very well preserved Frankish, so from 1200 to early 1400s harbour And we also have in some places that we have very well preserved Hellenistic tower underneath the Frankish remains that's been left visible. So I'm going to actually concentrate a bit on this area. We've done lots of other research, so Salken sauna and sub-bottom profiling in the parts under the water, but again, I'm not going to go into that. I'll just concentrate on the combining the line drawing with total station. So total station work with photogrammetry, and most of the walls are quite easy to document. So that you basically just need somebody who has patience in the water, so going with a mini prism over the blocks, because they are in very shallow water, or sometimes even slightly over the visible above the water. And so we started doing that in 2007. And I think we had quite a few seasons that we were drawing, because the harbour remains are quite massive. So there's several hundred meters along the shoreline, and we have the biggest breakwater actually extends 150 meters into the water, into a depth of 7 meters. And then this is perhaps even more typical situation, that the archaeology architecture is something like 6 centimeters the surface. So there you need actually 3 people. So you need the most important person is the snorkeler. So she or he is the one who decides where you take the points, and then the one who holds the prism, the feet you can actually see, that person communicates with the total station. So basically walkie-talkie going through, picking your lines, what type of materials they are. And we didn't have long seasons. We usually have sort of 3-week seasons in late August, September, but we needed a few of them. So it's relatively slow work doing this. So we started in 7. We didn't quite finish in after the 5th year, 2003. From 13-17, we ran the season. Concentrate quite a bit on other work, so not just documenting in the latter years. When it gets to be deeper, if you are a good swimmer, you can actually work quite decently precise with a long prism pole. So it's that usually sort of up to 5 meters in depth. You can actually record the blocks as long as the surface is calm. So that's where the difficulties come. That when you come into days that you have waves, it gets to be almost impossible to document in the water. And that we know that there is a shift in the weather patterns from last week of August until the end September. So there's only a few days there when there's waves. So mostly it's quite calm weather, and that's where we do the field work. And when it gets to be deeper than 4 or 5 meters, then you need divers, and then it gets to be extremely slow if you want to get the signals on top of the ground. So we did limited work with those, but we did do some of the deep blocks that we have. Our foundations of the breakwater go to sort of 6-7 meters. And then my best friend in 2016 is the drone. So that's since we do have very good visibility in this site, so it's a busy route. So you do get boats, but the current harbour is 1 kilometer away from the ancient and medieval harbour. So we do get nicely, very clear visible. So we have more than 10 meters of visibility under the water, and there's a brief time in the morning. So before you get, basically, sun is just rising, and all of the waves from the previous evening have died down, and before the wind starts, so that you basically just might have tiny surf ripples. Sometimes it's like almost oil the surface, and then you have perfect visibility into the water from the air, and it's quite interesting. So I just wanted to find, so basically every morning in 2016 and quite a bit also in 2017, I was at the beach. August sunrise, I think it's sort of 6:45. So you're there 6:30 to make everything ready, and then see what happens. Is it possible to make model? And there are many mornings when it actually is possible. And this is combining the line drawings from the total stations. So the data, all of the lines are color-coded with the yellows and the reds and the blacks. They are actually our total station measurements from 2007 to 2016. And then the model under it is based on the photogrammetry in 2016, and it's a 3D model. So from the aerial photo. So there, I didn't actually know that it would work, because you have a problem with the refraction, so that the sight lines, how they go from air to water, you always get a bending, and that means I had a guess that you could actually correct it by putting in loads of control points into the sea. So you actually to the model and measure those in with the total station with precision. And I'm just going to show the Greek tower. So we have the W1 is a Frankish wall that's part of the city wall. S1B actually then the Frankish tower that extends on the north side of the Greek ones, and they left the Greek remains to be used as basically stone quarries. So they recycle all the materials they can, and then probably at some point they decide that they're more likely they're already at the sea level at that point. They leave the blocks there to support because they're building on sand. So they leave some of the Greek structures just to support the medieval ones, and that's the 3D model. So or done from the aerial images, and then that's the one where it's been textured. And here it's actually not a large area, so I think I have about 10 fixed points in the sea that are measured with sort of centimeter precision, and that way it does make it possible that it throws off where the photo of the photogrammetry has been taken. So if you look at I should actually do a slide of it. They're a bit helter-skelter, that they're not the position where the photos have been taken. So they come with an angle, but it doesn't really matter, because what really matters is the model under the sea. And here's then you do see that there's some waviness that comes out of the surface ripples. And that's where when you do, like here, the sides of the blocks, even though they're straight, then the photo scan can actually make them exactly straight. So that's how it is. But they do match pretty spot on. So at least the good thing is that we do have the line drawings from the total station that we can then superimpose on the model. And I was testing a bit also the precision of the data, and so coming up with statistical analysis of the sizes of the blocks, and you end up with sort of centimeter scale errors in the sizes of the blocks if you do it just from the 3D photogrammetry model, and in most cases that's fine. So but here, when I was doing the statistical analysis of the foot unit being used, I needed the data from the total station line drawings, the aerial drone photos, and the 3D model is not quite enough to be. I'll work it a bit more. Quite interesting what comes out from the total station data, that we have a foot unit that nobody has ever proposed as a Greek foot unit, so 34 centimeters, and there's quite a few suggestions that where the ranges of the Greek foot units lie, and this is one that has never been suggested before anywhere in Greek architecture. So actually shows that we should have the data to analyze and not randomly assign the foot units to that approximately fits. Okay, I try to avoid not to go too much into how we use the data, to just actually present what are the advantages of doing one way or the other. And one good thing is also that when you have the 3D models of both the line drawing, you can actually use it as the basis of the reconstructions. That's still ongoing process of what the harbour installations would have looked like. Costs. So I had a brief word about it, but then something like, okay, I think the prices are coming down the whole time. So I got a new drone last autumn, and I think I paid some like 1,200 for that one, and it is a step up from the previous one I had. So toad stations, yeah, you now buy a new one. I think I actually managed to talk with a local UK company last autumn, and we got the new ones for £5,000, which are very good ones. So that's 2,000 to 5,000 is something that's you should have. Digital cameras. I'd say tests with students, and sometimes it works well when you have a very good mobile phone camera. They work out perfectly fine for the model, so you get them spot on. So you don't even need the DSLRs or okay, it does make certain light conditions when you're difficult, and having a good camera helps out a lot. And the laptop, okay, this one is already, I think I bought it almost 5 years ago, and then it was something like €1,000, and it's still running very strong, and then I can do most of my analysis on this one. Desktop, if you actually get good processor and loads of memory, and that makes your life much easier. So software, the academic licenses are very reasonable. So 400 is something that I think the maximum for the licenses, and then we have the freeware alternatives as well. And 3D scanner, now the prices have come down, and I think that's because of what happened with photogrammetry becoming mainstream. So the scanner producers, they realized that they can't keep the 50,000 asking price anymore. So a couple of years ago, I bought a 3D scanner for the institute, and that was about 20,000 at the time. And that minimum cost is zero. So if you work with freeware and you have your laptop, which is hopefully half decent, you can actually do very good, at least object documentation with 50 photos with the freeware package out there. But there are some cases where the combining the two methods don't always work brilliantly, especially around the time constraint. So I'm just going to briefly go through a couple of case studies that are temples that I was working with the excavations in the 1990s. So I've done, in both cases, quite a lot of the hand drawing documentation of the buildings. And so the Temple of Athena is, Pausanias writes about it, that it's the biggest and most impressive temple of the Peloponnese. But it probably is not, it's actually not the biggest. It's still more, I'll show a couple of things that I did very quick, 2 days in 2016, 17. So I was there with the intern of the Finnish Institute. So we had a 2-person team for, I think we're 2 or 3 days, 2 days at the site. And during the days we cleaned the effort has done a wonderful job of cutting the grass around it, but then most of the grass from the trimmers actually flew on the temple foundation. So we brushed all of the foundations clean, and then I ran the drone, and we, as much as we could, so in between that we're doing something else, we documented at least precisely the size of the foundations and where they lie, also with the stations, and that's done in about sort of half a day's work or even less. That's just getting enough of the documentation of the size of foundation. But last, there's one other thing that asked you for a workshop is looking at the of the blocks in the. I had done preliminary work in the 1990s, but realized that I didn't have enough documentation of the precisely how the drum repairs had been done. So I went very quickly I think it was in February, beginning of, or it might have been very bad weather, so pouring down. The site was flooded, and one of the drums was under the water, and I only had one morning to do it, so that's I couldn't even go back the next day. Just to show that it can be done, there's one of the drum repairs here. See the on the block, and then that had been probably the two chances that either that broke when the block was already at the site and being carved, but it's also possible that they're actually testing the block, that how deep the crack goes, that is it possible to use the drum. So then often you will actually make a sounding hole into it, but then if you're going to use the block, you have to somehow repair the cutting that's been done. And just as you see, so the cut is over there, so it's actually a junction that's very difficult to document, and 3D we're there, and I'm going to go to the next one, and here you see better. You do see the place where it has actually been out, and zooming in on it, it's sometimes the tool marks come out much better in the model. So if you're very careful how you do the photogrammetry, you will get the surface texture actually better, or the, let's say, surface geometry better than so they almost fade away entirely with the it's almost impossible to the blocks in a way that the tool will become visible. So I was quite impressed at how well they actually come, even with the quick documentation with the photogrammetry. So here I'll start doing, think of taking in any kind of line drawing, that this is actually something that works perfectly out from the photogrammetry documentation. And then as the last case study, just a bit more, that's another temple, so on a mountaintop that we excavated, or almost on the mountaintop, already in 1997, and with the University. We are now finally putting together I think we actually have the publication more or less for after 20 years that it's on the temple itself. But then I took the opportunity to go for actually 2 days to the site. So again, see what can be done quickly with a drone and cleaning and a small team. The green dots is sort of the GPS points that I took just with a normal GPS, and then you can, it has a few meter precision, but once you then triangulate the positions with the total station, you can get at least locally consistent networks. It might be slightly off what comes to the north angle or the rotation of the grid and its position, but it will be actually more or less spot on. So you can use just the GPS for that. And when now the new GPS systems that actually use the second signal from the satellite is going to be even more precise. So you're probably going to get into less than 30 centimeter precision from even your mobile phones. And then the red dots are the ones that I used for the photogrammetry, the positioning of the model. And that's also one thing that's when you do mind that don't just use 4 points when locating the model. So the more you have points where you can actually tie the model, the better your results are from the what comes to the. And then this was only done with drones, and what I always try to do is not to take the views that run horizontally over the target, but also take diagonal shots, because that way you get when there's something standing up, that it's going to be, otherwise you get fairly imprecise the geometry on the vertical walls. And I was quite happy with the results, especially that we basically had 1 day of cleaning and then starting with the shooting, and then the following day, just the morning to clean up and run then the final model of the temple foundations. And one thing I wasn't actually thinking that we were there midsummer 2017, and when I was running the final model of the site at 3.5 meters, the sun is exactly overhead, and when you're running the shots vertically down, then the drone becomes into almost every single picture, and that you can do processing, you can get rid of it, but that was a bit of a surprise that's when I had the every single shot at the drone shadow in it, and as you see, the red lines are there, that the view control lines that we had time to do with the toad stations, and they actually give the overall building and its orientation. And I'm actually going to be looking, what I more always do is here with the red angle, I have extra scales in the models. So I'm not using them to scale up the model, because that happens with the 3D toad station targets. But they're there to control what's the precision of all of the work. And here, okay, that actually doesn't look well, but it's the shots are done in the corner, so they're off by a centimeter. But actually, the scale length when you take it's off by a millimeter. And I was quite surprised by it. And that tends to be often that if you have enough of control points on the ground, your model ends up being actually but much higher than what's usually promised by the precision of the models. But that's and that seems to be fairly consistent. So if you're careful when you do the photogrammetry, even on large complexes, you end up with millimeter scale errors rather than the centimeter that you could be expecting. I tried it with quite a few sites, and that's been systematically the case. So they are basically spot on when you have the control scales on the ground and on the. And just to show, so that's the wider area of what it looks like from the drone. So that's at a, I think it was 10 meters height that I took the photos for the model, and then 3.5 for the temple itself, and they worked quite okay, and that's the team we had. So Professor Erik Ösby, Professor Anne Brisbard, and Picasso, who's just actually finished her MA at Oxford, and you can, with this small team, you can do quite a bit with photogrammetry and also limited toad station drawing. Thank you.
Thank you very much, Jari. That was fantastic.
Oh, thank you.
So we can leave the live stream for a couple of questions. So maybe let's start with the less problematic ones. Does anyone want to start?
Thanks, thank you so much. That was absolutely fascinating. Also lovely to see all this beautiful sunshine and less than sunny summer. So I have a rather naive question for you. Talks a lot about these great successes and things that work for these companies. Is there anything you've tried that hasn't worked so well and that other people should avoid?
I'd say you make sure that you have the time. So that's never do what I've had to do in several cases. That you run the last set of photogrammetry shots and then you don't process them, and because then always come up with surprises the following day that you're missing something, but then there's good, if you do the good planning and basically overshoot, so do too many rather than too little, you can always then chuck out the ones that are not needed. And I'd say there is the sort of biggest thing to learn is that so process everything the same day you take it, and because then you remember what you've done, where the control points are, and if you don't do it, you're going to run into at some point when you come back to it after 2 years, and you can't find your control point lists, and I'd say that's the biggest mistake you can probably make. And I've done it a couple times, that at least sort of you start going through your data that was it now this one or that one, and especially some places where we realized, but okay, that only comes in the post-processing, that we actually had a problem with the differential GPS. So we're using the same system, and the following year we had a 70 centimeter difference in the differential GPS points, and we ran it, but then with the second system, and we came up that must have been some kind of a problem with the ground signal that's in one of the years, and I couldn't get anything out of the companies that were supposed to be. They would not actually reply to my emails when I said that we have a difference of 70 centimeters in a place where okay, it was a slightly difficult one where we're working, but it's still not something that should happen. And when you're doing sort of city grids type of things, then the one part of where you have actually surveyed, they were not, even though it's a rectangular grid, they were not exactly hitting. So at least we spotted it, and then finding out that how to remedy it is a large issue. So.
One more question. Okay, I'll ask one then. Okay. I was really interested in this idea of combining technologies together, and I think that 3D technologies in particular, they really give their best when they are used together. I recently joined a workshop that was combining RTI with spectral imaging. It was really cool. So I want to ask you, what would be your dream interaction between 3D technologies that doesn't exist yet?
I think it's already coming there. So there are some articles that basically do the from the 3D, so either from scans. Well, I think mostly being used from scans. They actually do the hand drawing. The type of images automatically, and that means that's. But one thing actually I didn't actually emphasize enough, that the good thing with the total station drawing is that you teach your students to use the total stations. So that's a skill, and there's repetition after repetition, and they have to actually change the positions. So they after 2 weeks they can sort of they're basically professional surveyors, and they don't forget it. So I've had quite a few of the students from the fieldwork courses then going to be the surveys on field projects, and I say that's probably one of the very good things, and I would still, even if you can actually do the drawings by hand, I think I'm going to keep on training the students in this way, because then they learn also to read the architecture, and if you make everything automatic, they're not even looking what's there, so they don't know how to read what's on the ground, what are the materials, and if you just start trusting entirely the technology, you might end up with loss of expertise there too.
Well, thank you. Do we have one last question before we stop the recording?
We can go to sort of difficult questions.
Okay, so the audience is hesitating, so let's stop the recording and we can move to a more informal setting. Thank you.